Hey guys, in this video I am going to teach you what to do if you end up with negative exponents in your powers. So negative exponents are not allowed whenever you are simplifying powers of exponents. So when you end up with a negative exponent, you need to put it in the denominator and make the exponent positive. So a lot of times you'll hear us say that you need to flip it, and that's what we'll be talking about. So for example, if I have x to the negative third, that's the same as x to the negative third over 1. So I would need to flip that fraction and put it in the bottom of the fraction. That makes it x to the third. But I can't leave this with nothing up top, so I put a 1 as like a placeholder. So it becomes 1 over x to the third, and that would be it. That would be simplified. This other one, on the other hand, I have 4 to the negative second, which again, if I wanted to make the exponent positive, I would make it 4 squared on the bottom. Again, I need a 1 up top. But 4 squared simplifies to 16, so this is the same thing as 1 over 16. Okay, but what about if it has more than one base? Same idea. Anything with a negative exponent gets flipped. So you need to pay attention to the exponent for each base. The 5 has an exponent of 1, which is positive, so that one would not be flipped. But the x and the y both have negative 2's, so both of those would go on the bottom and become positive exponents. So x squared, y squared goes on the bottom, while the 5 stays on top. Similarly, over here, if I have multiple things going on at once, the first thing I'm going to want to do is simplify as much as I can. So I have 9 divided by 3, which is 3. X to the negative third over x to the first. So remember, you keep the base, which is x, and then you subtract the exponents. So negative 3 minus 1 is negative 4. And then similarly with the y's, I have 5 minus 2, which is 3. Now, take a look at all the bases. The 3 has a positive 1 for an exponent. X has a negative 4, so we're going to have to flip that. And y has a positive 3. So that one's fine. We can leave it alone. So the 3 and the y to the third stays in the top of the fraction. And I'm going to put x to the fourth on the bottom so that I can make that exponent positive. So the key idea here is that you need to look at one base at a time. Okay, but what if the negative exponent is in the denominator? Same idea. You need to flip it so that you can make it positive. Again, focus on each base. The 6 has an exponent of 1, so that won't need to be flipped. The x has a positive exponent, but the y has a negative. So the 6 and the x are going to stay up top, but the y to the third is going to come up to join it. Now, technically, this is the same as over 1, but you don't need to write the over 1 part. So we just leave it as 6xy to the third. If you put it over 1, it's not incorrect, though. All right, same idea here. 12 over 16, if you put that in your calculator as a fraction here, we can simplify it. So I'm going to take 12 over 16 as a fraction and simplify it. That would be 3/4. And then I have x to the fifth over x to the negative fourth. So keep the x, which is the base, and 5 minus negative 4 is 9. So that would be x to the ninth. And then I just have the y on top. There's no y on the bottom, so that won't change. And all of my exponents here are now positive. All my bases are different, so I know I'm finished. That would be the simplified version here. So again, if the negative exponent is in the denominator, you need to put it in the numerator and make it positive. All right, lastly, what if the negative exponent is a power to a power? My suggestion is to simplify, just like we did before when you learned about power to a power, and then deal with the negative exponents. So for me, I'm going to look inside the parentheses first. I have b to the 10th over b to the third. The bases are the same, so I'm going to keep the b and subtract the exponents. 10 minus 3 is 7. That's still in parentheses and still to the negative second power. Now I have power to a power, so take that and distribute it. That becomes b to the negative 14th. But I can't have a negative exponent, so I need to flip it. It ends up going in the bottom and becoming b to the 14th, and I have to put a 1 up top as a placeholder. And that would be it. All my bases are different, and all my exponents are positive, so I'm finished. Same idea here. Negative 12 over 4 is negative 3. X to the negative 5th over x to the negative 3rd. Keep the base, which is x. And then negative 5 minus negative 3 is negative 2. And the whole thing is being raised to the negative 4th power. Now, I personally don't like to do any flipping until the very, very end. So that's what I'm going to do here. Now, the negative in this case right here in front of the 3 is part of the base. So it's got to stick with it. The negative 4 is going to be distributed to the 1 and to the negative 2. So when I do that, I end up with negative 3 in parentheses. Remember, it's part of the base. And 1 times negative 4 is negative 4. And then x to the negative 2nd to the negative 4th. Keep the base, which is x. Negative 2 times negative 4 is positive 8. Okay, my bases are different, but I have this negative exponent here, so I need to flip that to make it positive. When I do that, I end up with x to the 8th on top, and negative 3, still in parentheses, to the positive 4 on the bottom. But one more thing, I want to simplify that negative 3 to the 4th. So I'm going to make sure that negative 3 is in parentheses, and I'm going to raise it to the 4th power to get 81. So this is the same as x to the 8th over 81. That's my final answer. All of my bases are different. All of my exponents are positive. So that's the key here. If you have any negative exponents, you must flip them to make them positive, and you know you're finished when you have all different bases and all positive exponents. And that's it. That's how you simplify negative exponents.